All right. Good afternoon. My name is Nicholas Dritas, and I see by now familiar faces. That's my third session in TechEd. They say by now I should be able to do 4 since I did 3. But that's maybe a little too much. We're going to discuss this afternoon. So just to give you what we discussed so far in TechEd from my side, we discussed best practices on SSIS. We did some discussions around fast track and some introduction to parallel data warehouse. So both of them were done yesterday. Today we're going to discuss kind of a more broad and interesting subject. What are the largest SQL projects in the world? And you may say, or you may ask me, how do you know this stuff? So I'll tell you why I know this stuff. I'm part of a team in SQL Server. I'm part of the SQL Server team, and we have another team that is called Customer Advisory Team. So a lot of teams. The role of our team is to engage with the most exciting, interesting, large, complex, nobody wants to touch SQL projects in the world. I happen to cover Asia Pacific. I've been here for about 5 years now. And the scope of our team is to work with tier 1 customers for either OLTP or enterprise data warehouse projects. So this presentation is kind of an accumulation of a few, not all, a few of the key projects we've done that kind of showcases in production what are the biggest limits or the highest limits we expect to reach in different factors or aspects of SQL Server. I'm sure many times you've been asked, how big a database can be in SQL, how big a table can be, how big a cube can be, different metrics that shows the scalability. And there are lab results and different guidelines, how big these sizes can be. The presentation today is from real customers doing real work. Actually, we went to each one of them. We ran SP space used because we didn't trust the numbers. Make sure they're telling us the truth. So it is as close as possible to that. So let's go for it. The session objectives are pretty simple. Learn and talk. We're going to discuss about these large SQL projects. First of all, what are the sizes? And we'll have some insights. What were some of the major architectural decisions and directions to achieve these levels of scalability? So here's one of the magic tables, and we're going to talk in more details as we go through that. This is in production today by companies. So the largest single database we have today is 70 terabytes. Today, the last few months. You need to be careful when you're sizing that. I'm not saying multiple instances, multiple databases. I'm talking a single database. And we'll talk later on how you back up or you restore such a thing. It's a pretty, yeah. So it's nice to keep pumping data there. Then you say, let's back it up. What? We don't back up. Yeah. We're unbreakable. Yeah. What? Oh, thank you, Ed. Largest single table we have today is 20 terabytes. And by the way, these sizes, you may ask, oh, you may have a lot of pictures there, and blobs and stuff like that. This doesn't have pictures or blobs here. All these numbers assume very large data sets. Biggest total data in one application we have today is 88 petabytes running on SQL. When I'm saying one application, it implies many databases. The point is the application handles and manages all this number of databases as a single unit. It knows how to go, where to direct the traffic. But as far as we're concerned, it is one big farm of servers supporting this application. And we'll talk which companies doing that. The highest database transactions per second for one database we have recorded today using perfmon is 130,000 transactions per second we have. That's a lot of transactions per second. Fastest I/O system, you remember yesterday we were talking fast track and the balance stuff and all this beauty going on over there. 18 gigabytes per second. That is actually the newest EMC Clarion box to give us that has about 2 terabytes of flash cache. It's pretty cool. So it has all the hardware guys. Ooh. That's the latest, actually. One of our customers that needed this I/O got it. They pay through the roof. But the idea is it gives you that level of, it's a new level of cache within the SAN enclosure. So it has all the disks. The disks, you have the level 1 cache, level 2 cache, and introducing level 3 flash cache, 2 terabytes on the SAN. So it's good stuff. Fastest real-time cube, 5-second latency. Real-time cube means that the relational database that is supporting the cube is changing real-time. We have updates, and then the cube reflects the changes without having to reprocess the whole cube. As you know, the cube supports real-time roll-up partitions, and the best we can have achieved so far is 5 seconds. Data load for 1 terabyte, that is a big benchmark everybody's pursuing, 20 minutes. So we can load 1 terabyte in 20 minutes. Do we have SSIS guys here loading data? Few of you? I guess everybody after my yesterday's talk left. 1 terabyte in 20 minutes it's very fast, and we'll see how we achieve that. We're using a lot the NUM architecture to create true parallelism across 64 cores and create this level of scalability. Largest single cube in analysis services, 12 terabytes. Analysis services, guys? Don't be shy. 12 so whomever is analysis services can appreciate 12 terabyte single cube. I mean, that's huge by any metrics. Cube is about 20-30% compressed of the relational database. So you need to multiply that 1.7 actually, 1.7? Something like that, to get the size. So it's a huge size, the relational database. When you get my slides, because this table was getting too long, there are more things to talk for some other items, some interesting points. But this is where kind of a cherry pick of the main metrics we see. So where these metrics came from? They came from a collection of companies here that we tried to catalog by different workload and discuss a little more what kind of levels they're achieving. VLDB is a very large database. PanStars. PanStars is an organization that collects and catalogs pictures from pretty much the sky and the universe and galaxies and things like that. We say more than a petabyte. It's actually more than 88 petabytes by now. We'll talk in more details. MySpace, myspace.com, if you know those guys. It's one of the first, before the Facebook and all that. I mean, that was the first social networking site. They have about 500 servers right now managing 1 trillion rows of information. Itaú Bank is down in Brazil. This guy is growing about 80 gigabytes a day, and they plan about 50 terabyte system by 2010. The US Department of Agriculture, again, grows about 90 gigabytes a day. The interesting part is Danske Supermarket. It's out of Denmark, retail analytics. And we have a single fact table there with about 11 billion rows today. That's one of our biggest tables we have in production today. Mission critical. So large US financial organization, when you see things like that, that means either we don't have permission to tell you their name, or they're owned by the government by now. So it's a government organization. You know the joke of GM, you know the cars? What GM stands for? General Motors? No, it's actually Government Motors. Bad joke. Big Win. Big Win is one of the biggest betting organizations in the world. If you follow soccer or football, I don't know how you call it here, they have the biggest advertisement. They're sponsoring the best teams in Europe, Milan and Real Madrid and Bayer from Germany. These guys, they have more than 4 terabytes of database. But since we're talking for Big Win, look on the high availability disaster recovery. We're tracking that very closely with them. They have achieved 100% uptime for 2 years in a row of their system. And this is a high betting, one of the biggest transactions per second system we have in the world. How did they do that? How they do that? They're reading and following best practices. There's no magic, frankly, guys. What they did is they did invest to their DBAs. They built an excellent DBA team, one of the best in the world. They train them, they empower them, they trust them. So that's how they achieve uptime. A lot of you are SQL guys. Some of you have been exposed to Unix and Oracle. I dare you, go to an Oracle DBA or administrator and say, show me your procedures. They'll bring some thick book over there of procedures. And you have the SQL guy, give me your procedures. Pretty small. So best practices play a big difference. Some other highlights over here. We'll talk more details. Let's see. MySpace is working a lot for high availability as well, as you see at the bottom. The 10+1 clusters. A lot of companies, they're taking advantage of this new SQL, Windows 2008 R2 feature that you can have up to 12 nodes actually within the cluster. So MySpace is going 10+1, 10 active, 1 passive as a failover. So they expect much higher levels of availability. Regarding data warehouse, some interesting stuff. Centipede. Now, Centipede is one of those government projects you'll never know much about it. That's a code name. That doesn't tell you anything. We can't talk much about it. But it's 490 terabytes in 9 data nodes. That's a big system. They're capturing so much information that's beyond belief. That's all we can say about it. Web Trends is one of the data warehouses. It's a BI company in a way. They're tracking network traffic on the internet. We have them about 50 terabyte system by now, 5 terabytes on an analysis services. High volume OLTP is always exciting. We have this large financial organization again in US. We're scoring, that's the one that scored 130,000 transactions per second system and less than 50 millisecond latency per transaction. These are strong SLAs that we have with them on SQL Server. Make sure that we always meet that. For many companies, by the way, like this, on that level, there is a program in SQL Server. It's called SQL Server Replay. So where we're capturing the profile of their application, and we keep replaying it as we have new versions coming out to make sure we're meeting those levels of performance, or, of course, make them better if possible. One of my favorite sites, it's Gmarket. They're out of Korea. It's one of the biggest auction sites, like eBay style. Have you heard of Gmarket before? How about eBay? Yeah. So what Gmarket did, they bought eBay Korea. Now they're even. They have about 80% of the market, about 3 million users every day online auctioning stuff. Very interesting, very exciting market. 23,000 batches per second system, Superdome, 64 cores, scale up, high scale up system, about 60% utilized during the day. So exciting stuff. So let's go some more details on these projects. First of all, for very high scale, this is some of the features of SQL Server you should deeply consider as you're planning and architect a very large scale system. Compression. Both database and backup compression. It should be planned and implemented. Data compression, as you probably know, it's only on an object level. We don't have necessarily, there's no database compression concept. You have to compress a table explicitly or indexes. Okay? So we have 2 levels of compressions, row and table, row and page, I'm sorry. Data warehouse benefits a lot from page, about 60–70% savings, when a traditional OLTP system, probably raw compression, will benefit better. I'm not going to go into details of that. I'm assuming you kind of know that. SAP by now has enabled by default raw compression with the newest release that supports 2008 and above. So that shows trust in that level. Table partitioning is one of the best things you need to plan for. That's how you can work better with more contained chunks, especially as you like to remove data, archive data, load data. partitioning strategy is very important. In up to R2 version, the released version, we were supporting 1,000 partitions per table. With the latest service pack on R2, we support 15,000 partitions per table. And I think that is back to 2008. So both 2008 and R2, the latest patch, is 15,000 partitions per table. And why 15,000? I don't know, maybe we'll do 30,000 next time. It's just how much time we have to test this thing, frankly. Service broker, we'll talk for that. Has anybody used service broker here? There's one person, 2 people, 3 people. All right, cool. 4, 5, all right, don't be shy. You like service broker? Is it cool stuff? Yes. So people haven't experienced service broker, we encourage you to use it. A lot of high-end systems, this is not nothing new, this is not SQL, this is a common architecture from the IBM mainframe era. Messaging, queuing, no? So service broker has a guaranteed methodology of delivery where every message, when you're interacting with the database, is not a direct command to the database. Instead, you're putting a message in the queue in the service broker, and the service broker, in a guaranteed sequential fashion, serves these messages. You may say, wow, that sounds like an overhead and a bottleneck potentially. It is not. I mean, we're dealing with thousands of messages per second. That's how the scale of the engine is to provide this level of scalability. So we'll talk for that. DDR as well is a great strategy as well, data-dependent routing, where you kind of have multiple databases, but by using DDR strategy, you kind of treat all these databases as a single unit. But at the same time, you can scale out your load. And always the big question is, should I scale up or should I scale out? And we'll see some of those strategies there. All right. So what do we have today for scale up? What's available today at the hardware vendors and for Microsoft? So SQL 2008 R2, with Windows 2008 R2, we can support up to 256 cores. So we broke finally the 64-core limit we have. And up to 4 terabytes of RAM in a box. I don't think I've seen a server yet with 4 terabytes RAM, but the new Superdome has 2 terabytes of RAM coming with. So that's a lot of RAM. We support up to 14 PCI Express cards. You may say why this is important, because if you ever do direct attached storage, that's important, because that's how we can map to those PCI cards. And for scale up, this is the how you can categorize a scale up. The 50 terabyte, 70 terabyte database, 130,000 transactions per second, 18 gigabytes throughput, 600,000 IOPS. That's a very fast system. You know, IOPS is the main measurement for disk capacity and performance for OLTP system. It's the IOs per second. It's from the performance monitor. And the 1 terabyte load per system. Okay, actually I was wrong when I said, okay, so this is the latest number. 1 terabyte load in 7 minutes using 256 cores. So the 20 minutes before I told you that was in a 64 core. So the more cores, the merrier. Again, we're using NUMA. NUMA is the non-uniform memory address. And the idea with NUMA has become so prevalent now in this size of systems. You know, 256 core systems is too many cores. It's huge, the space. The cores and the 2 terabytes memory, 1 terabyte of memory. So NUMA allows me, if you don't know, to create, it creates kind of a pseudo nodes, kind of mini servers within the server. So it brings closer an association of a particular core and a particular fixed amount of memory, you know, contiguous memory. So it says from this address to this address of memory, that memory belongs to that core, and it never changes. So in 256 cores, we can create it creates 256 NUMA nodes, and each node can be accessed actually by an IP address. If you haven't done that before in SQL Server, you can enable NUMA nodes, and the idea is then you're using each NUMA node as an interconnection, as a separate connection to do the loads. So each path, when it loads data, it's totally independent from the other. It can be fully parallel. It's a very nice thing. If you search for NUMA and SSIS, you'll see a lot of those techniques. So scale out. This is classic SQL Server. It's not parallel data warehouse, so we're still talking for SQL Server and relational. There are a few projects that they have employed that techniques, and we'll talk how they did that. We have the 88 petabyte system. That deploys about 3,000 servers, SQL servers, as a single application. And then the most exciting part is down here when we have 100 terabytes per instance, 5 databases across 11 servers. So we'll go in more details for these projects, how they did that. So for the data warehouse first, PanStars, as we said, it's the largest, and I think it's panstars.com if you search. It's the largest astronomy project in history. So they have, actually, I've been to one of their sites in Hawaii. They have a telescope where the lens is pretty much the size of this room. It's huge. So they take pictures. I say, how many megapixels? You know, I don't know if you guys like pictures. You know, you always say, how many megapixels is your camera and this and that. So theirs was 1.5 gigapixel. So I kind of felt a little, you know. Anyhow, my 12 megapixel camera, it wasn't enough. So the level of detail is very high, and of course the size of the files is very large. I mean, these images, they're very high detail. So what they did is they put 100 terabytes per single instance of SQL Server, and then they put in there five databases of 20 terabytes each. The reason they did that is because they didn't want to add more resources in the server, more I/O, more HBA cards, more memory. They wanted to keep it up to that level. So overall, we have about 1 petabyte today managed, but it's getting much, much bigger. Actually, we're in the multiple petabytes by now. We're adding 5 terabytes per day of systems. And what we do is, for high availability, talking for challenge here, we're relying on backups of the input files for now. So we'll talk for other strategies for backup. What this guy is saying is, well, this is not such a mission-critical system. What they're doing is all the input files, they back them up in case something catastrophic happens, they have to reload them in the system. So that's one strategy, per se, to minimize cost of backups. We'll talk for other strategies, though, soon. For data warehouse, another industry or vertical that is very excited about capturing a lot of information is telecoms. CDR, call detail records. So telecoms know everything about us. You know, when we call, how long we talk, who do we talk to. We all have GPS by now in our phones. We know where we are. You think your GPS is off, but it's not. So they know where you are. You know. The big brother is watching. So they're going to start eventually, I know, streaming ads. Oh, you buy McDonald's, you know, here's a coupon, $1 off. Go there and show them that. You know those things coming? You don't? Okay. Prepare for spam galore very soon. So this is the slide. Actually, my phone recently, Nokia, pushed down, and I think we're working for the Windows Phone and the iPhone. They start pushing down spam filters already, preparing for that. So you can start, like your Internet Explorer, you can start filtering spam. So this telecom, which we're not going to name, they have 70 terabytes relational data database and about 4 terabytes the largest cubes. They're running Itanium 64 core, and they're loading 1 terabyte in 30 minutes. So similar strategies for the loading. They split it across 64 paths using the 64 NUMA concept I was telling you to reach that level of 1 terabytes. Some of you already heard our website, sqlcat.com, sqlcat.com. Please write it down, go there. We have a lot of details around these strategies and around, more specifics. Like we have a nice white paper, how to load this 1 terabyte in 30 minutes, what it will take. It takes a lot of cores. So talking in the data warehouse arena, one of my favorites, Hilton Hotels. I was with them for 3 years. And no, I haven't met Paris, because people asking always that. If you know a little of the industry, the hotels in the hospitality industry, every morning, every hotel, they do forecast. They have to forecast every morning. Every day they treat it like the beginning and the end of their business. So the trick over there is if you book in hotel rooms, you may have heard it sometimes, call the hotel directly in the afternoon. That's the best rate you can get because they get in panicking. They had to fill up the hotel. Unless they're full already, then you're in a bad spot. But every morning, they're receiving the actuals from the day before, and then they have some kind of data mining engine that kind of gives them a little forecast of the rates. And, you know, it's a projection, kind of futures. And then they establish the rate for the day that goes back to the reservation system. So at Hilton, they needed to make sure they have fresh data every hour. So the challenge over there is to rebuild the cube, full cube rebuild every hour, and support about 450 to 450 users. And I don't have it over here. We have about 4,000 hotels across the world from a single data center. All right. Nothing to worry about that. If you get these slides, and you will get them, we have in several of them a case study hyperlink. Please go over there. There are a lot of details and videos about these configurations. Since I did this project, I was lucky enough to grab the latest production architecture we have, or they have. Let's go a little briefly on that. So the challenge we had in our scenario is this is a 7x24 system. So that is one requirement. I cannot have even a second offline from analysis services. If you are an analysis services person, you may know every time you rebuild the cube, you need to take even a second offline or a full database lock to commit your changes. So if that happens, again, I'm not 7x24. Not to mention I'm running the risk of not committing the process because there are long queries running in front of me. So the processing has to commit, has to wait for the long queries, and in the meantime is holding everything back. In this scenario, what we did as a strategy, as you see at the bottom in the middle, we have a server that is called Analysis Services for Cube Processing. It's the cube processing server that all it does is every hour wakes up and processes the cube. And then we have a layer in the middle of 6 analysis services. It's a farm of analysis services that they have 2 instances. One that is always queried, and the other that is standby to receive new data. So my web farm is connecting all the ways to the instance that has been identified as queryable. Okay? When new data comes, when the processing finishes, it synchronizes all the 6 servers, the instances, they are ready to receive data, not the queryable. And when they're all in sync, and I know that from integration services, they're all in sync, then what I do is I change the connection string and pretty much drain the cluster on the top to point to the new instance that has the new data, and then in a way the instance is reversing role every hour. Okay? With this trick, you're getting 7x24. Again, there is a white paper out there, how to go into more details to do that, but the idea is to use a dedicated processing server, and then take advantage of 2 instances plus the cluster drain idea that you can switch the connection string to point to another instance. Okay? So the system works quite well since August 2005, as the document says here, and Hilton is still working. Of course, it's been sold by now, but Stay Mart, it's one of our first fast-track case studies. It's a big retailer in Florida. They have about 250 stores. And being a retailer, AS400 was the database of choice. That's where it was their data warehouse in AS400. Nice green screens and big boxes of paper was the ad hoc analysis. So it was kind of an unfair result, comparison, but we went down from 14 hours to 3 hours. We took a nice fast-track architecture system, very well balanced with I/O and the cores. And we built about 4 terabyte of data warehouse. So the case studies here, if you're interested to know more about real life fast track, based on what we discussed yesterday, this is one of our case studies you can refer to and see how they did that. Oops, battery stretch. That's not good. Hold on. Aha. The system works. Okay, so MySpace.com is a big website, social networking out of California, out of Beverly Hills. Actually, it's right behind Hilton when I was there with them. Today, they have about 500 physical servers. They're adding about 1 a week of SQL servers. So DBA dream over there, every server, 1 server every week. They have about 1 petabyte of data to manage, and the thing grows and grows and grows. So people, you think everybody's using Facebook, that was our hope, so you don't have to add so many servers. Well, that's not the case. MySpace is still well and alive. There is a great article for the architecture. It's not from our Microsoft, it's from another magazine, Baseline magazine.com, so there is a nice article there. But mostly I wanted to discuss a little with you for the solution and how a system evolves. And you have to make some architectural decisions, not from the beginning, but maybe as the system grows. We very seldom have the luxury or the epiphany when we build a system. We know how big the system needs to be 3 years, 5 years from now. You have some agile technology to adjust. So look at MySpace, because we were with them from the very beginning. They started at the beginning. They put up a website, myspace.com. I remember that. It opened. And I was there with the owner. I was like, man, anybody will come? I mean, I don't know. Do they know us? Totally insecure. We don't know what's going to happen. After a few months, we had 500,000 users. We're very excited. Wow, we hit the 500,000 mark. We were kind of conservative, 1 database server, 1 to write, 2 to read. We were happy. Then after a few months, we hit 1 million. Like, whoa, we need to do something here. So we're doing a vertical partitioning to kind of solve a little the scalability. We created separate databases. That's a classic thing when you have a 3-tier system, web application. You may be pushing some elements up closer to your web level, like for lookups and for other things to take the load out of the main database. That's what we call vertical. You kind of slice it like that and you move it down. Then after a few weeks, things started snowballing. We went to 3 million level. So we kind of gave up on the scale-up stories as well. If we keep growing like that, we're going to keep getting limits. So we went down to the scale-out story. And we'll scale out for them, it was more data DDR. This is how it's a data-dependent routing. So every user was assigned to a particular database, and that was your database. You would never move to another one. Okay? So that was kind of the style. When we hit 9 million users, we went to ASP.NET. Caching. Caching tier helped us a lot. They were using application-level caching. There are some different applications. There is a third-party application. It's called Scale-Out. Has anybody heard of Scale-Out? A few of you? Okay. Of course, by now we have a Microsoft solution, Velocity, which is very similar, distributed managed cache on the application tier. And when we hit last year 26 million users, believe it or not, they were still in 32-bit. So now we're in 64-bit. We're excited about it. And they're using Service Broker. So everything now in MySpace is Service Broker. We're handling about 30,000 messages per second via Service Broker. So that's a strategy for them kind of to scale and guarantee delivery of messages. Because they were kind of worried, they have all this distributed scale out, 500 servers. How do we know messages go to the right place, they arrive, they always complete? So Service Broker has been very helpful to them. They had 7+1 clusters. They're going to 10+1, as we said. They do extensive testing. These guys are very good in that. Every time we release a patch, they do test it. They take our, they have some benchmarks, some test suites to make sure they pass before they do the patching. We see about 3,000 to 7,000 connections average per server in their system. And we have 2 data centers for DR, and we're using a SAN replication, SAN snapshot. When we say DR, it's a little different from HA. DR typically expects, few hours outage. DR is a major event. That means your main data center is totally not accessible. So the clustering that meets the high availability within the data center, and then the SAN snapshot means the DR. Another is always a tendency to say, well, I want my DR to be very quickly up. That's fine, but that's not typically the reality. I mean, DR will take you a few hours to restore. Big win. Largest blah, blah. All the fun stuff. Sports, poker, casino, skills, games. I'm not encouraging you or endorsing you to go there. Disclaimer. But they're getting a lot of traction, a lot of information is going on over there. The exciting stuff with them, of course, is the high level of transactions, but mostly for the high availability of the system. They have a very big system. They have a 128 core today Superdome running in both sides, and it's 80–90% utilized probably. And they wanted very high level of availability. So they put synchronous data mirroring between 2 towns in Austria. It's Austria, so the distances are small. So 12 kilometers for them was pretty far. Luxembourg, I guess, is going to be even better. This added only 1 millisecond delay in the transaction. So when you put synchronous anywhere in any large and complex system, ensure the first thing you need to measure is the delay, the latency you're adding to each transaction. It may be acceptable, it may be not. That brought 4 nines availability in the system. And by 2008, 2009, we went up to 100% uptime. And this is public information they're sharing with us. They have also deployed replication and log shipping for some other databases. And database mirroring, they're pretty much using it for the betting database. So the point over here is we have different technologies with different latencies that can be used in a mixed mode. Sometimes you like to use log shipping or data mirroring or replication even, or what have you. Each one, log shipping doesn't have much overhead. On the other hand, though, it's not as real-time or full sync between the 2 applications. If you ever plan to do mirroring, we found that the sweet spot is up to 40–45 kilometers apart. If you go more than 45 kilometers, the latency gets too big. Actually, the last test we did in Australia, 45 kilometers will give you about 500 milliseconds delay on top of your current transaction time. So that's kind of long. You don't have much choices over there. Either you get a very fast pipe, and that's expensive, or you go asynchronous, and then you take in some chances that you may have some loss of data. So Big Win is one of our big customers, as I was telling you. We're hitting 30,000 database transactions per second, 2 billion rows. That's one of the biggest tables we have. And this is one of the first guys that went to one of the latest boxes we have. They were in a 64-core Itanium box. They went to 128 cores with 256 gigs of RAM, and they saw about 400% improvements in performance. And we have some websites over here with case studies and information how this was done. The great news for us for SQL engineering is that we see these great linear or even algorithmic performance improvements, doubling the cores and doubling the memory. This is very happy for us, very exciting to see this scale-up story. Any questions? So I can drink some water. Exciting stuff. So retail application, which we cannot talk about. Who's that? but it's a big store, 1,200 stores in the U.S. Starts with letter T. The exciting part here is 15,000 cash registers, keep feeding real time, pretty much the system, pumping data into the system. We use clustering, and the exciting part here is the cubes. I mean, it's not that large, but again, for analysis services, 1.5 terabyte system is quite large for us. So 15,000 cash registers, they're going pumping data. We had SSIS, NUMA, you're getting the theme a little, when you're doing large sizes, the theme is kind of repeating how to handle those sizes. One of the challenges here we had is they wanted to load a dimension in analysis services, 25 million accounts. Is that big? That's big. So if you know analysis services, the cube, the space it uses, the memory space, is a Cartesian product of all the members of each dimension. So you're putting 1,000 times 1,000 times 10,000 times 25 million. Woo! Huge space of memory. So it was challenging. We tried to do some stuff. We put more memory. Things are good. All right. For high availability a little, geospatial. Geospatial comes more and more. Nothing has to do with spatial, by the way, yet. It's a geoclustering, you may call it sometimes, but this is geospatial. The idea is you're pretty far. You're quite far from one data center from the other. We're talking, Asia versus US or for Europe. And the idea is how do you maintain this kind of data consistency so far apart between the systems. So this is a particular example. It's a company, it's called Agoda, agoda.com. It's a company of Priceline, actually. They're based out of Thailand, and they're doing a lot of web, it's a web travel agency. That's where you're booking hotels and things like that. So the problem is how to maintain, they had the data center in Hong Kong and the data center in New York, and the thing is how to maintain those two in sync, but still use them both locally to serve USA customers and Asian customers, but still be a failover site for one another. So you cannot really use geoclustering, you cannot really use mirroring, because the main requirement was both of them to be active, updatable, and in sync. That doesn't sound complicated. Oh, and to make it a little more exciting, they had 500 tables with cascade updates, deletes, constraints, triggers, 3,000 store procedures. And this is a .com company, so every day the schema changes. It's wild. Probably from these 500 tables, like 450, nobody uses them, but nobody dares to touch anything there. Like, it's working, don't touch it. Actually, they have a 6 months moratorium. Nothing is touched from July till end of January. So this is the summer season. Then you will go to some holidays and all that. So, like, don't touch anything. This company is growing 500% a year, just to tell you the growths you see and be a CTO there. So we tried clustering to discuss the clustering. As we said, that doesn't really work because it's complex, granted, but again, the distance was quite far. We do geoclustering between Hong Kong and New York. That's very expensive. Plus, I couldn't use both nodes. Still clustering is active-passive story. Database mirroring and log shipping, it can be used as a high availability scenario. But again, the secondary database cannot be written. In log shipping, there is an option to read the destination, but you cannot write to it. Same thing with mirroring. Mirroring, you cannot write to that. So what we used was peer-to-peer replication. Peer-to-peer replication is an extension of the transaction replication, which it allows you to have both nodes, actually multiple nodes in a ring, up to 6 nodes actually, and they're all multi-master, multi-update, multi-synchronized, and they're all available to be used. So this option allowed us to use all the existing servers, enable all servers in a multi-master function, and the beauty is any side of this ring can be brought down without affecting the users. That was the goal. In 2008, we even allow you live, as the system works, to drag and drop new servers to the ring or remove a node from the ring without having to stop the application and make sure everything is in sync before you do anything like that. So peer-to-peer is extremely exciting technology. And what happened? This. A lot of pretty pictures here. This is what you show to your CIO and says, okay, you did your job. Okay, thank you. So you feel free to use it. Okay, let me tell you what the only 4 things you need to look here. The others is for presentation purposes. You see I have Asia Core 1, Asia Core 2, US Core 1, US Core 2. And some supporting databases for the website. So in my scenario, I have 2 centers, one in Asia, one in USA, and I established a peer-to-peer ring. Actually, it's not a ring, it's like a square between those 4. Okay? One thing to remember, one rule of thumb, when you have peer-to-peer, every node to be highly available and make sure all the data is there, you need at least 3 arrows to reach. When you have 1, 2, 3, at least, reaching a node, we always have a path to get the data from. That's kind of the theory there. The reason we added 2 cores or 2 servers per data center, you may say that looks kind of redundant. Why do you replicate also within the data center? Okay? For 2 reasons. One is because we wanted to add, this is my high availability in a way, within the data center. The second is, this gives me a much better throughput and faster synchronization between the 2 data centers, because both locals will replicate to each of the nodes on the other side. There's no smartness over here. What we expect is, if you make a change over here on the US Core 1, because it's local, extremely fast, within milliseconds, it's going to be in the US Core 2. And both changes, they're going to go to Asia Core 1. And whomever arrives first wins. So this one works. This one says, you're already there. Let me take the next transaction, and I'm going to send it there. So it's kind of load balancing between the 2 systems. How much is the impact of that? If I remove this one, we see the latency increasing by 40–50% of the other system. So if you ever do peer-to-peer, this is a trick. Add more servers. It's very cheap. It's very simple to add more servers within the same data center, and those all participate in the ring. So not necessarily every node has 1 server. When I say before 6 servers, can be 3 here, 3 there, and that increases your throughput of your replication. Okay? Best practices. Again, we have a nice paper at the bottom. Make sure you use R2, 2 nodes, use store procedures with pool as delivery method. That's the best and fastest way. Store procedures are very well tuned to go around, very compressed, instead of the full commands and all that. And use R2, as we said. And if you ever have WAN issues, because the sites can be far from each other, in our case, we use the software WAN accelerators, Expand, expand.com. They make a software WAN accelerator or compressor. About 200% improvement we saw by compressing the WAN. Again, this is only when you have a slow WAN, but software WAN accelerators do help a lot. Replication. All right. I have 10 minutes. All right. Almost there. So let me step back a little. When you're architecting, you have several options, as we said. So we saw some big systems, both OLTP and data warehouse. What kind of available options we have? So for data tier architecture, to scale it, one option is to have multiple databases in a single instance. So in my picture over here, I have 1 instance and then a few databases spread in a SAN of 3 disks. That's a simple data architecture. When you want to increase the rate of data availability, you have to establish the RPO and RTO level, how quickly you want to switch and how much data loss you may incur or data unavailability you can tolerate. So failover cluster, you don't lose any data But if you know from experience, it could take a while to switch over. Do you have these experiences in clustering that takes a while, and you wait and you wait? We'll make it better, but for now you have to wait. So it can take 45 to 90 seconds or a few minutes, depending how many things, how many transactions it has to roll back and roll forward, this thing. So what other options we have? As we're saying, moving forward, we see companies doing this kind of configuration where they have multiple and even different sizes of clusters, active clusters, and then they're putting a single passive node to support all this infrastructure. We don't really see necessarily pairing an active with a passive always. You don't really need to do that. I mean, a single passive is very good architecture. Now, database mirroring gives you much better performance, especially when you want to have fast switchover. Synchronous, as you see, we're losing no data, we're fully in sync, and we can switch much faster than clustering. We can go down to the 4 to 15 seconds switching. Asynchronous, you may be a few seconds behind, and it takes a little longer to switch over, but asynchronous doesn't have the problem of the latencies. It doesn't add any latency in your application, but it doesn't guarantee 100% synchronization of the information as well. So each one of them has its place. We discussed that already. This is another option to have a high availability scenario by employing peer-to-peer replication. This is very nice because there's no latency, it's multi-master, and pretty much everything depends on the path and how quick is the path. It can be from very slow to very fast, local, so it's a very flexible configuration. So as far as scaling, okay, so how do I manage this 80 terabyte database? How do I back it up potentially? How you build an index on a trillion row table? Maybe you don't. So answer, we have to break it into manageable size pieces. I'm sorry, this is nothing earth-shattering. That's all it is. I mean, we have to make it smaller. We cannot handle that. It's very hard. Any system, Oracle, IBM, doesn't matter. Treating a petabyte or a trillion row table as a single unit, nobody does that. They're always partitioning these places. So what do we have? As we said, we support partitioning. You can do partition on a table level and or index level. We highly suggest you correlate, you use the same partitioning function both for your data and your indexes, so they're well aligned together. There is a feature, you can search it in the books online in SQL, that you can co-locate also tables together within the same partitioning schema. This is when you're joining often same tables, like order header, order details, things like that. If you collocate them within the same partition function, the joins we've seen up to 8 times improving in performance. So it's called table collocation. Another option we have is if we have multiple tables, we can go down to the local partition views. So we can have a few big tables broken down in still big tables, and those big tables being broken down into partitions and indexes, and then create a view on the top that you union all those tables. SQL is quite good into understanding this is a view, and when you pass parameters, the plan is well done, and it knows to which table to go and use the indexes. Another architecture, when you're getting even bigger, is to go cross-database partition view, where you have like MySpace, where you have multiple databases hosting those big tables, and then you do a view across databases. You're still on the same instance and on the same server, but you have multiple databases. The beauty of having multiple databases is what? What do you think is the biggest benefit, having 2 databases instead of a single in the SQL Server? I'm sorry? Redundancy, yes. Memory, yes. Different buffers. That's content. What do you mean? Which resource? What is the biggest resource we gain by having two databases? I'm sorry? Spreading the I/O. For which part of the database? Come on, come on. Come on. Who said it? There you are. I have a share to give away. That's the last one. Large. You look like large. I would have said extra large. So the beauty of having two databases, you have in two transaction logs. It's very, very important. These huge databases, transaction log is nice to have it separated. Don't ask me if SQL will have multiple logs eventually and things like that, because I cannot tell you, but we may have. Who said that? Distributed partition view. So this is an old technology since SQL 2000. The idea over here is you have multiple servers now. So you see how we keep scaling. You know, you have a single instance, multiple databases in the same instance, multiple databases in different instances. Now we're going across servers, physical servers. Again, SQL Server is quite smart to understand where each table and database exists, because still the indexes and the plans are hosted by the base tables. The views don't really know much of statistics and indexes, so it goes down to that level. But that works quite well. We have a lot of big-size databases using this technology where multiple servers union to create a logical view of the big table. You heard that a few times. This is the strategy of data-dependent routing. And if you go and Bing or whatever, you'll see a bunch of articles on this methodology. The idea here is when the user logs in, you see number 1, 2, 3, let's follow that. On the top left, the user logs in the web tier, and then he connects to a login server, and that, based on the username or the server name or whatever, it receives a particular connection string to connect to the right server. So all the servers at the bottom, it's a set of data servers that receive, or the app server directs you to the right database server based on who you are, what region you are, things like that. Again, nothing new, nothing earth-shattering. It's a very traditional, old style, but it works very, very effectively, because then you can easily add more data servers over here and serve a larger number of users. MySpace is using that. Other big systems are there using that. A little from the talk, talking for data warehousing. Fast Track, it's a good story for scale-up story. Very well-balanced system between cores and I/O performances. This can scale up to 48 terabytes. These are systems, they're already pre-configured, appliance like from IBM or Dell and HP. Pretty much you call them, you order a size, they ship it to you, you plug it in, and things happen. So this is what I had so far. By the way, please take these slides. I have notes in every slide. More things to say. Probably next year if you see me, I'll have a new slide, new customers. Things keep evolving. So the bottom line is SQL Server can handle any size you need. Database size, transactions per second, concurrent users were very comfortable and very confident with the tool. Here you saw a small sample of very big customers across the globe, different verticals. Hopefully you got a little glimpse of what they're doing. You kind of see some patterns, the way you're handling data loads, the way you're handling backups perhaps, or how you're routing your data. The marketing spiel, SQL Server is enterprise ready, but we're engineers. We're very excited about the project and the program. SQL 11 or Denali is around the corner. If you're in MSDN or whatever, make sure you start testing it. We have some new exciting improvements about it. So it is a journey. It's not going to finish for the next many, many years to come. I mean, we've been around for a while. New technologies come. So that's all I had for now. If you have a few questions, let me know. I'll be around. Otherwise, maybe I'll see you in the party tonight. Thank you very much.